Okay, this is a section that we're going to spend multiple days on. This is section 6.4. We're on page 390 and we're talking about algebra and the trig functions. And this is a section that's going to lay the foundation for a lot of what we're going to do in both this chapter and again in chapter 8. Okay, not so much chapter 7. Chapter 7 really just deals with graphing trig functions. But chapter 8 will use a lot of algebra as well. So the first thing to understand, guys, is a notation issue. And we've already seen it with the box from our unit circle quizzes, where we have cosine squared theta plus sine squared theta equals 1. This is not the same as this. Because on the second one, what is being squared? The theta, the angle is being squared. So if we're talking about cosine of 30 degrees squared, that means we have cosine of 900 square degrees. First of all, I have no idea what the heck a squared degree is, what that represents in the real world. Okay, but certainly that really has very little to do with cosine of 30. That is not what we're talking about with this identity. With this identity, it's the entire cosine function that needs to be squared and the entire sine function. That's why we write it this way. What this means the same thing as is this. It's the whole function value that's being squared. And the whole function value is really what coordinate for cosine? X. And the whole function value is really what variable for sine? So this is really just our x squared plus y squared equals 1, but using our trig functions. Okay? So it matters where you put the squared. It makes a difference. Okay, so that's the first issue, is you need to make sure that you put those in the right places. The next thing you want to talk about is just something simple like combining like terms. So for example, if we have 3 sine squared theta cosine theta minus 5 sine squared theta cosine theta plus 7 sine theta cosine squared theta. Am I allowed to combine any of these terms? The first two, because the variable parts match along with the exponents. Okay, the variable parts, you think of sine theta as a variable and cosine of theta as another. So this is almost like 3 s squared c minus 5 s squared c plus 7 sc squared. Which of those are like terms? The first two. What would those first two combine to give you if it was just s's and c's? Negative 2s squared c plus 7sc squared. What is this going to give you? Negative 2 sine squared theta cosine theta plus 7 sine theta cosine squared theta. It's exactly the same thing. Do you guys see that? But instead of having individual letters as variables, now we have trig functions of variables as our variables. But it works the same way. So that would be your answer. What if they ask you to multiply this out? 2 sine theta minus 3 cosine theta, quantity squared. And we want to expand this thing. Well, what does it mean when we square something that has more than one term in it? What do we have to use? We have to FOIL it. So that means I need to put a second parentheses, 2 sine theta minus 3 cosine theta. What are we going to get when we do first times first? 4 what? Good. 4 sine squared theta. What do the outers give us? Almost. Yeah, minus 6. What is it? Good. Sine theta, cosine theta. The inners give us what? Negative 6. Sine theta, cosine theta. And then last times last gives us plus 9 cosine squared theta. And then the middle terms combine, and so you end up with 4 sine squared theta minus 12 sine theta cosine theta plus 9 cosine squared theta. So do you guys see that this doesn't work any differently than S's and C's or X's and Y's? It's exactly the same thing.
Could you put cosine theta, sine theta, like is that?
Yeah, it doesn't matter which order you put it in. Typically, I would actually put it in alphabetical order, so I would typically put cosine first. But it really doesn't make any difference. It's up to you. Because multiplication is commutative, right? 3 times 2 and 2 times 3 are the same. Yeah, it's acceptable either way. Good question. All right. What about something like this? What if they ask you to factor and they give you t squared plus 5t plus 6? What would this factor into? T plus? Okay, everybody see that? Well, now what you're going to have, instead of t plus 2 times t plus 3 equals t squared plus 5t plus 6, they're going to ask you to factor tangent squared theta plus 5 tangent theta plus 6. Do you guys see it's the same problem? What's it going to factor into now? Tan theta plus 2, tan theta plus 3. Do you guys see it's the same thing? So the trig functions work along with algebra exactly the same way as regular variables. It's just each of your trig functions is treated as a variable. That's all. Okay. Now, on tonight's assignment, which is going to be the first 18 problems, what's going to happen is you guys are just going to be working with things of this nature. Okay? I guess there's one more example I want to show you. But typically you're going to find that most of these problems have a part A and a part B. Typically what will happen is part A will ask you to do this one, and then part B will ask you to do this one. Do you see it's really the same problem twice? Structure-wise, it's the same. The only difference is instead of a t, you're using tangent theta, or tangent A, or tangent beta, or whatever variable letter they give you. Okay, make sure you use the correct letters. Okay? All right. The last thing I want to talk about, actually there's two last things I want to talk about. One thing is if you have something like c minus 1 over 1 minus c, what does that equal to? First of all, do those cancel? No. Now, if they were pluses, would they cancel? Yes, because addition is commutative. 1 plus c and c plus 1 match, but not with subtraction. But how can we make it so that they do cancel? Good. Take one of them, it doesn't matter which one, I usually do the top, and factor out a negative 1. We're not, multiplying by negative 1, we're factoring it out. When we take that out, it becomes negative c plus 1, which is the same thing as what? So that's how you flip a subtraction problem around. Now what happens? They cancel out, leaving you negative 1. So that's one thing to be on the lookout for, is that if you have two factors that are subtraction problems, but they are reversed, you can reverse one of them back by factoring a negative 1 out. Now you cannot multiply by negative 1 because then you'd have to do that to the bottom, and that would flip the bottom around too, which doesn't do us any good. It would reverse both of them. Okay, the other thing I want to talk to you guys about is what happens when you have something like this. If you want to simplify this, what do you have to get before you can add these together? Common denominator. So what's the common denominator? So this was already S on the bottom, so it stays the same. What do I multiply the bottom by to change it into an S? Which means we have to multiply the top by an S, and so this would be CS over S plus 1 over S, which would simplify to what? You guys see where this is going? What's the common denominator going to be? So this is going to become sine theta on the bottom and sine theta on the bottom. This was already sine theta, so the 1 stays. Here we had a cosine theta, and we multiplied top and bottom by sine theta. So this becomes cosine theta, sine theta plus 1 over sine theta. Again, do you see that it's the same both ways? And typically this would be part A, and this would be part B, is a lot of times what you'll see on the homework. So even though you'll notice that most things are part A and part B on the homework, it's really the same problem twice. Once you do part A, you know exactly how to do part B. You just have to put the trig functions in instead of the single letters. Okay, anything challenging about that, guys? Pretty easy stuff, right? Okay, so that brings us to the homework assignment.